Assalamu alaikum. I welcome all of you to the 11th lecture of CS218 Data Structures and Algorithms. In the last lecture, we were introduced to singly linked lists. We implemented a class to create and manage a singly linked list. We saw pictorial depictions of code fragments, and we found time complexities of all codes. The topic of this lecture is linked structures, and we use chapter 6 of book 1 for this topic. In this lecture, I show you how to use the class functions that I created in the previous lecture. Remember the class list node? I am going to implement more functions using the class functions of list node. My first objective is inserting a node containing val after the node containing x. So first I am going to take a singly linked list and see if it contains a node that has x. Two things can happen. Either it will have a node containing x or it will not have a node containing x. If it does not have a node containing x, I will do nothing. But if it has a node containing x, I will insert a node containing val after this node. This is what I am supposed to do. The first thing is to import the class list node. The function is called ins_after. It takes 3 arguments: the head pointer of my singly linked list, the value x, and the value val. Now, if you remember, the insert function that we implemented takes a pointer as input. It takes a pointer, let us say p, as input, and then it inserts a node after the node pointed to by p. But right now, we don't even know if there is a node containing x. So what we want is a pointer to the node containing x. Who will furnish that? Who will tell us if there is a node containing x or not? The search function. Head.searchX. I am calling the search function for the head pointer of my singly linked list, and I am asking it to search for x in the singly linked list. Again, if you can recall, the search function will return a 3-element list. At index 0, there will be either true or false. True if there is a node containing x, and false if there is no node containing x. And in element 1, there will be pointer to the node before the node containing x. In index 2, there will be pointer to the node containing x. So I call the search function for the head pointer, giving it the target of x, and whatever the search function returns, I store it in my own list called res here, which is result for short. This is the result of the search. The best case happens when the first node contains x. Why am I calling it the best case? Because in this case, the search function will have to make just one iteration, and after one iteration it will see that the first node contains x and it will return back. So the search takes O1 time in this case. Now since there is a node containing x, res 0 is going to be true. Res 1 is none. See, res 1 is supposed to contain pointer to the node before the node containing X, but there is no node before the node containing X. Hence res1 is none. Res2 contains pointer to the node that contains X. We use insert function of list node to add a node containing val after the node containing X. We call the insert function for res2 pointer and we ask it to insert a node containing val after the node pointed to by res2. Now, the question is, how much time does the execution of the if comparison and the body take place? If you go back, you will see that the insert function takes O1 time. The insertion takes O1 time. From this we can deduce that this case, which is the best case of ins after function, takes O1 time. I am continuing with the same objective. I want to insert a node containing val after the node containing X. Now you might be wondering what would be the worst case of this algorithm. The worst case happens when the last node contains X. How do I know that this is the worst case? This is the worst case because the search function will have to do as many iterations as the number of nodes in the list to finally get to a node which contains X. So the search takes O(n) time. Now since the search finally finds a node containing X, I can say that res0 is going to be true. Res1 is going to point to the node just before the node containing X. So I can say that res1 will be pointing to the second last node. And res2 will contain pointer to the node that contains X. What did I set to do? I wanted to insert a node containing val after the node containing X. So can I say that I want to create a new tail node and the tail node will contain val? Yes, I can say that. We use insert to add a node containing val after the node containing X. Again, I call the insert function for the res2 pointer and I ask it to insert a node containing val after the node pointed to by res2. Again, the insertion takes O1 time. Since the search function and the if are appearing consecutively, one after the other or sequentially, so whenever you have lines which are in a sequence, you add their O notations. The search takes O(n) time, the insertion takes O1 time, the whole if takes O1 time. O(n) plus O1 will give you O(n). So the worst case takes O(n) time. But there is one more case that I want to discuss with you. Let us consider a linked list in which no node contains X. So we start from the head pointer and go all the way to the end of the list. But we do not find a node that contains X. My first question is, how much time would the search function take? The search function will have to check every node in the list, and let us suppose that there are n nodes. So the search will take O(n) time. But since there is no node containing X, res0 is going to be false. And if res0 is false, the if comparison will be false and we will never move into the body of the if. And this situation will also have O(n) time complexity, because the two lines that are being executed over here are the res equals head dot search x line and the condition of the if. The condition of the if executes in O1. The search takes place in On. Again, since they are consecutive, we add their O notations, and the final O notation is On. Do you think this is one of the worst cases of this algorithm? Do tell me via email or comment in Google Classroom. Now we change our objective slightly. We want to insert a node containing val, but before the node containing x. The first thing we do is import our class list node. The function is called intsBefore. It takes 3 arguments: the head pointer to a singly linked list, the value x, and the value val. Again, the first question is there a node containing x? Because if there is no node containing x, we will do nothing. But if there is a node containing x, then we will proceed with insertion of a node containing val before it. So who will tell us if there is a node containing x? The search function. We call the search function for the head pointer and ask it to look for x. The search function is going to return a 3-element list, which we will store in our own list called res. The best case happens when the first node contains x. Why am I considering this to be the best case? Because in this case, the search function looks at the first node and finds x. So the search takes O1 time. And then it returns. So when search returns, res 0 is true because it has found a node with the target element. Res 1 is none. This is because the target element is in the first node and there is no node before it. And res 2 contains pointer to the node that contains x. So this is the information returned by the search function. We move to the if condition, where we check if res 0 is true, and this is true. Then we move to another nested if, and we check if res 2 points to the same place where head points. Res 2 is head, means both are the same addresses or both are the same pointers. This condition is going to be true every time res 2 and head point to the same node. If you look at the figure, you will see that indeed res 2 and head point to the same node. So we will move into the body of the second if. And here we do 3 things. First, we call the init function of the class list node. We pass it the value val. It creates a new node and a pointer new points to it. Here you can see the freshly created node. The second task is to make the next field of this newly created node point to the node containing x. In other words, we make the next field of the node pointed to by new point where head is pointing. And the third thing that we do is make the head pointer point where the new pointer is pointing. So the head pointer starts to point to the node containing val. Now, if you start traversal from the head pointer, you will land on the node containing val. From there, you will go to the node containing x, and then you will move to the other nodes in the singly linked list. You can see that we have effectively added the node containing val before the node containing x. In the end, we return the head pointer, and when the function falls out of scope, new and rest2 also perish or fall out of scope. So the user who gets the head pointer gets a singly linked list in which the node containing val is before the node containing x. Now the two nested ifs take O1 time, and we have already said that the search takes O1 time, and since these are consecutive, we add the O notations. If you are considering the O notation of the return statement at the end, that is another O1. So all of this brings us to the O notation of this case, which is O1. Now let us look at the worst case of this function. We call the ints before function with the head pointer to our singly linked list, the value x and the value val. Then we call the search function, give it the head pointer and ask it to search for x. Suppose that you have a list in which there is no node containing x. We say that this is the worst case. Why? Because in this case, the search function will have to go through as many nodes as there are in the linked list until it returns and tells us that there is no node containing x. So the search takes O(n) time. And when it returns us the 3-element list, since there is no node containing x, res0 is false, which means that the condition of the first if is false. So nothing executes in the body of the first if. And then in the end, we return the head pointer as we received it. We make no changes to the singly linked list. Now if you ask me for O notation, I already know that the search takes O(n) time, and then I just do a comparison for the outer if, and then I return the head pointer. So all of this is O1. So I can say that this is On. We want to insert a node before the node containing X in the singly linked list shown here. Run the ints before function. Draw figures for all steps. Can this be considered the function's best or worst case? Now, enough about insertion. We are going to talk about ways to delete a node containing X. If you remember, we did do a delete function in list node, but that function was taking a pointer and then it was deleting the node which was after the node pointed to by that pointer. Here we are not working with pointers. We want to delete a node containing X. So the first question would be, does a node containing X exist? Because if a node containing X does not exist, we don't have anything to delete. So when we start, we import the class list node. Now I am changing my strategy a bit. Previously I was explaining the code to you. Now I am going to explain the situation and help you write the code or figure out the code by yourself. The function that does what I want to do is called del node. It takes the head pointer of my singly linked list and it takes the value x. Obviously we do not know if the singly linked list pointed to by head contains a node that contains x. So the first thing we do is call the search function. We call the search function for the head pointer and ask the search function to look for X. And the search function is going to return a 3-element list. So let us suppose that there is a node containing X. That is, the first element of the returned list is true. Now, if there is a node containing X, again there can be two things. There can be X at the very first node or there can be X somewhere else. So let us suppose that X is present at the very first node. In this case, res 0 is true, we know that. Res 1 will be none because there is no node before the node containing X. And res 2 will be pointing to the node containing X. Now, what do I want to do? I want to delete this node containing X. So if res 2 is head, this means res 2 and head are pointing to the same node. When will this condition be true? This condition will be true only when the first node contains X. This is what I want to do. How do I do it? I write head equals head.next. Head was previously pointing to the node containing X. Now it is pointing to the node after the node containing X. Anytime you write this line for a pointer, the pointer will advance to the next node. Now if you start traversal from the head pointer, you will go to the node after the node containing X. I can say that there is no pointer in the singly linked list which points to the node containing X. This means that I have effectively deleted the node containing X. So this was one scenario. But the other scenario where our else would execute will be when X is not in the first node of the list but some other node. Res 0 is already true. Res 1 will point to the node before the node containing X. Res 2 will point to the node containing X. What do I want to do? This is what I want. And for this, I can call the delete function of my class. If I call the delete function of my class and I give it the pointer res1, then it will delete the node after the node pointed to by res1. This is what I write, res1 dot delete. Now when you do traversal of the singly linked list, you will come to the node pointed to by res1 and then you will move to the node after the node containing X. No pointer in the singly linked list points to the node containing X. This means that the node containing X is not part of the singly linked list. It has been deleted. At the end of the function, I am going to return the head pointer to the user. And this can be easily done by writing return head. Figure out the best and worst cases for this function and their time complexities. Suppose that somebody gives me a list of values and he wants me to create a singly linked list and store these values in it. This is what I am going to do now. I am going to build a singly linked list. First, I import the class listNode. The function is called buildListVal. Val is a Python list containing the data we want to store in a singly linked list. And val must have one or more elements. How do we take care of that in the code? Throw in an assertion. Len of val must be greater than 0. Otherwise, the user should be told that we cannot build a list with no elements there. So, what to do here now? Take the first value in val, that is val 0, put it in a node and make a pointer point to that node. The code for this is simple. A is list node val 0, and the effect of this code you can see in the picture. We set a pointer b to point to this first node. B equals A. Why am I using a second pointer? I am using a second pointer because I am going to advance the second pointer. The question is, why can't I just advance the first pointer, A? I do not want to advance A from its position because this is my head pointer. I want a pointer to keep sitting pointing to the first node of the list. If I take just one pointer and I start advancing it, that as soon as I advance it, I will not have a pointer to the first node of the list. This will make my entire list inaccessible. If you don't have the pointer to the first node, if you don't have the head pointer, you cannot traverse through the list. You cannot access the list. This is why I use two pointers. A will stay where it is, and in the end I will return A. But B will advance. We run a for loop from 1 to n minus 1. We have already added val 0. Now we will progressively add val 1, val 2, all the way to val n minus 1. So the for loop runs from 1 to len val minus 1, steps 1 every time. In the body of the for loop, we insert a node containing val I after b. Currently, b is at val I minus 1. So we have to insert a node containing val I. How do we do that? We simply write b dot insert val I. This is the insert function of our class. It will insert a node containing val I after the node pointed to by b. We advance b to the node just created. How do you advance a pointer? B equals b dot next, right? So after you have inserted all the values of the val list, we return the head pointer. And what was the head pointer? A. The code will say return A. And see, this is your complete singly linked list, which we will now return. And the annotation is ON. Why is it ON? Because there were n elements in val. And first we inserted the first value, and then we inserted the n minus 1 values in a for loop. Hence it is ON. We want to build a linked list from user input. The function is called buildList. It does not take any argument. Write the body of this function, take elements as input and keep adding them to a linked list as long as the user wants. Return the head pointer of the list and analyze the function for time complexity. Let us do another activity. This time we want to insert a tail node containing X. By tail node, we mean insertion of a node as the last node of the singly linked list. So as always, we import the class list node. We call our function instTail. It takes head pointer of the singly linked list in which we want to do the insertion and the value that we want to insert. In our case, it is x. The pointer h points to the first node of the singly linked list. We want to insert a node containing x at the end of the singly linked list. Situation 1. There is no list. This means that h is none. How do we check for that? If h is none. So if h is none and we have to insert a tail node in a list that does not exist, how do you do that? Make a node, put x in it and return this node. Done. This is how we do it. We call the init function of the class list node, pass it the value x, it creates a node, it creates a pointer to that node, and we return that pointer. But this was when we were given a list which does not exist. So what happens when the list has some elements? Look at h here. It points to a list. I don't know how many elements there are, but there are elements. We do not want to advance h from its position because it is our head pointer. So let us take another pointer. Set a pointer a to point to where h points. In code I will write it like this: a equals h. We look for the last node, that is whose next field is none. Let us start a while loop and say while a dot next is not none, we advance the pointer a. How do you code that? A equals a dot next. So we looked at the first node, but the next field was not none. We looked at the second node, but the next field was not none. We keep on looking until we come to the second last node. The next field is not none. Then we come to the last node. The next field is none. And here we come out of our while loop. When we find the last node, we make a node containing x. How do you make a node containing x? New equals list node x. We set the next field of the last node to point to the newly created node. The next field of the last node. The last node is pointed to by a. So I can write a dot next equals new. And see what I have done? I have inserted the newly created node as the tail node. And then we return the head pointer h. Return h. So this is our singly linked list now, and we return it. Analyze inst tail head x for time complexity. Will it have different best and worst cases? So what did we learn today? We learned how to insert before or after a node containing a certain value in a singly linked list. We learned how to delete a node containing a certain value in a singly linked list. We built singly linked lists and we inserted a tail node in a singly linked list. We conducted complexity analysis for the running times of our functions. Things to do: read the book, note your questions and put them up in the relevant online session, and email your suggestions to me if you have any. Take care and Allah Hafiz.